So today we're going to be looking at direct variation and inverse variation just as a review. This is what we covered over the course of the last 2 days. Direct variation is a relationship whereby one variable increases as the other variable also increases. And I gave the example of y is equal to kx. K is called the constant of variation. We also discussed joint variation, where you have multiple entities that are causing the change in one of our variables. Then inverse variation is the relationship whereby as one increases, the other variable is going to decrease in value. Good example of this was distance. If I'm traveling to a certain place and it's 100 miles away, I'm going to get there faster, which means less time if I'm traveling at 50 miles an hour than if I'm traveling at 40 miles an hour. So as I increase my speed, the time it takes me to arrive goes down. That's inverse variation. The basic equation is y is equal to k over x. And along with that lesson, we also talked about combined variation, where we have a relationship whereby one variable changes either directly or inversely as to two or more other quantities. So that's what we discussed in the last 2 days, and that's what a lot of your homework was over. Today, what we're going to look at is solving rational equations. Rational equations are equations that contain one or more rational expressions. To walk you through the process, the first thing we want to do is determine any values that our variable cannot be, which means the denominator cannot be equal to 0. The next step is to clear all the equations of the fractions. Most of us don't like working with fractions, so we're going to clear the equation of all fractions by multiplying by the least common denominator, which means I need to find that least common denominator. Then we are going to solve for the variable using our regular algebraic techniques: addition, subtraction, multiplication, and division. Once we've done that, we want to make sure we check our answer, because we can have extraneous roots, answers that don't really work in the problem, particularly if it falls here where we have a 0 in our denominator. So let's take a look at this example. I want to solve for 4 over x plus 3 plus 5 over 6 equals 23 over 18. The first step in solving this problem is I want to get a common denominator and also figure out what values of x my solution cannot be. The only x I have in the denominator is right here, so x plus 3 cannot be equal to 0, which means x cannot be equal to -3. Now, my common denominator, I obviously have the x plus 3 as one of my factors. I have a 6 and an 18. Least common multiple between 6 and 18 is 18, so my least common denominator is 18x plus 3. Now, if I multiply every single term by my least common denominator, I will clear all of it from having fractions. But you have to do every single term. The only time you can clear equations of fractions is if you have an equation, which means you have something on each side of an equal sign. If I just have this part of it, I cannot clear my equation of fractions because I don't literally have an equation. With the equal sign there and something next to it, I now have an equation. So I'm going to clear my equation of fractions by multiplying by 18x plus 3. If I do this first term times 18x plus 3, my x plus 3's will cancel out. So I only have 4 times the 18. For the second fraction, I have a 6 out of the 18, so I just need to multiply by 3 in order to get my common denominator, and then x plus 3. So I'm going to multiply this by 3x plus 3. This last piece here, I already have the 18. I need the x plus 3, so I'm going to multiply the 23 times x plus 3. And that's what's shown right here. Now my next step is to go ahead and distribute whatever I can. So I have 4 times the 18. That's going to give me 72. I have really 15 times the x plus 3. That's going to give me 15x plus 45. And then the 23 times the x plus 3 gives me 23x plus 69. So that's what I have right here. Now I'm going to take another step, and I'm going to go ahead and combine my constants over on this side. If I had several constants on this side, I would also combine them. So I'm going to go ahead and take the 72 and add the 45. That gives me 117. And now, like regular algebra equations, I'm going to move all my x's to one side, all my non-x's to the other side. I'm going to choose to move my 15x over to this side so I have a positive value of x. So I'm going to subtract 15x from both sides, and then I'm going to subtract 69 from both sides. That gives me 48 is equal to 8x, and then all I have to do is divide by 8. When I divide by 8, I get x equal to 6. I do want to check my answers because in multiplying, I could have introduced extraneous roots. So always check your answer. First thing I'm going to check is if it's something that I know I cannot have. In this particular case, it's not a -3, so my answer is probably legitimate. If I substitute it back in up here, it does work out. So my answer checks. My final answer is x equals 6. Take a moment and let's try this one. I'll give you a couple of minutes to work it out and then we'll go over the solution. The first thing I need to do is find out what values of x it cannot be. I mean, only x is right here in the denominator, so x plus 3 cannot be equal to 0, which means x cannot be -6. Then I find my common denominator. X plus 3 is one of my terms. I have 2 and 10 as numbers, so my common multiple there is 10. So my least common denominator is going to be 10x plus 3. If I multiply every single term by that amount, in this first term, my x plus 3's will cancel out, so I just have 2 times the 10. In the second term, I need to multiply by the x plus 3. When I multiply by the 10, 10 over 2 is 5. So I really need to multiply that numerator by 5, x plus 3. And then this last term, I already have the 10. I just need the x plus 3. So those 10s are going to cancel out, leaving me with 19 times x plus 3. I then distribute. 2 times 10 is 20. I got this 15 times the x plus 3, which gives me 15x plus 45. And over here I have 19x plus 57 when I distribute. Combining my terms here that are constants, I get 65. And then what I'm going to do is I'm going to get all my x's to one side. I'm going to choose to subtract 15x from both sides to get my x's over on the right. Subtract 57 from both sides, giving me 8 on the left. So 8 is equal to 4x, divide both sides by 4, and that gives me x equal to 2. First thing I'm going to check is it a feasible answer? So far, yes it is. I can double check by plugging in the 2 into my original equation, and it does work out. Try this one. My only x in the denominator is this piece right here, x minus 4, which means x cannot be equal to a positive 4. Then I'm going to look at my least common denominator. I have a 12 and a 48. Least common multiple there is 48. And then I have my x minus 4. So I'm going to multiply by 48, x minus 4. When I do that, my 48 and my 12, those are going to reduce down to 4. And then I have x minus 4. So I need to take 7 times 4 times the x minus 4. For the second term, my x minus 4's cancel out, and it just gives me 9 over the 48, so 9 times 48. And then this last term, the 48's will cancel, and I got 55 times x minus 4. Once I distribute that, I'm going to get 28x minus 112 plus 432 is equal to 55x minus 220. I'm going to combine my constants over here, and then I am going to add the 220 to both sides and subtract the 28x from both sides. I'm then going to take the 540 and divide by the 27 to solve for x. When I do that, I get x is equal to 20. I look up here, that is fine. If I substitute the 20 back into the original, it does work out. So if you have an answer of 20, you are correct. As I mentioned earlier, sometimes multiplying by your least common denominator is going to introduce extraneous roots because you multiply by your variable, which means you're increasing the number of possible answers, but those answers may not be legitimate. I'm going to show you an example on this one. This one's going to take 2 screens, if you notice up here. And so if I use this as an example, I have 2x over x plus 5 minus this trinomial over the trinomial is equal to 3 over x plus 3. I'm going to go ahead and try to factor as much as I can, particularly down in the denominator. When I do that, I get this middle term being x plus 5 and x plus 3 down in the denominator. Now I can look for what values of x I cannot have. I can't have x being equal to negative 5 or a positive or a negative 3. So having known that, I am now going to get rid of my denominators by multiplying by my least common denominator, which is x plus 5, x plus 3. So when I factor that middle term, I get a denominator of x plus 5, x plus 3. That's actually going to be my least common denominator. And that means x cannot be a negative 5 or a negative 3. Now that I know my least common denominator, I'm going to multiply every single term in my equation by x plus 5, x plus 3. For that first term, the x plus 5s will cancel out, so I get 2x times x plus 3. The middle term, both of my entire denominator is going to cancel out, which leaves me with my original of x squared minus x plus, or minus 10. For my middle term, my entire denominator is my lowest common denominator, so that's just going to leave me with the numerator of x squared minus x minus 10, keeping in mind that it's preceded by a negative sign. And then my last term, when I multiply, my x plus 3's will cancel out, leaving me with the x plus 5 times 3. And so I end up getting this when I multiply by my least common denominator. Going on to the next slide, I've repeated a lot of what I already have all the way down to here. So when I distribute, that's going to give me 2x squared plus 6x minus my x squared plus x. Remember to distribute that negative sign out. And then I have a negative times a negative 10, which is a positive 10. And then over here, when I distribute, I get 3x plus 15. I'm going to combine all of my terms on each side of the equation. So I'm going to combine all my like terms on each side of the equation. That gives me the x squared plus 7x plus 10 on the left and 3x plus 15 still on the right. Now I'm going to subtract 3x from both sides. I'm going to go ahead and subtract 15 from both sides to get it in standard quadratic form, set equal to 0, descending powers of my x. I can then factor that x squared plus 4x minus 5 into x minus 1 and x plus 5. So that means my possible answers are a 1 and a negative 5. But if you recall, I'm going to look up here, x cannot be equal to negative 5. That was one of the things that would make my denominator 0. So I have to eliminate the x minus 5 as a possibility, leave me with one answer, that being 1. If I use 1 in my original, it does indeed work out. That's another reason why you need to always check your final answers when you're working out these types of problems. Try this one. I'll give you a couple of minutes to do it. So looking at my denominators, I know that y cannot be equal to 2. I'm going to look at my denominators to find my least common denominator. My least common denominator is going to be y minus 2 and 6. So when I multiply each term by that lowest common denominator, my y minus 2's in that first term cancel out, leaving me just 5 times 6. I do not have a denominator for the 2, so that means its denominator is 1. So I'm going to multiply everything by the 6y minus 2, so that becomes 12y minus 2. And then I multiply the 17/6 by the 6 y minus 2. The 6's will cancel out, leaving me with 17 times y minus 2. We distribute. We're going to then we're going to then combine all of our like terms on each side of the equation. And then I'm going to subtract 12y. I'm going to add 34 to both sides, giving me 40 is equal to 5y. Dividing both sides by 5, I get a value of 8. I look up here. My possible value of 2 is not true, but I have a value of 8. If I use that 8 in my original equation, it works out. So 8 is my final answer. If I factor that final term there, that z squared minus 1, I get z plus 1, z minus 1, which means I cannot have a positive or a negative 1 value for z. My lowest common denominator is also going to be the z plus 1, z minus 1. Multiplying each term by my lowest common denominator and canceling what is common, it gives me the 2 times the z minus 1 times z plus 1 equal to negative 2. Distributing, we get 2z minus 2 minus z minus 1 equal to negative 2. Combining my like terms, getting my negative 3 over to the other side to solve for z, I get z is equal to 1. As you can see, z is equal to 1 here, but up here, 1 was a constraint. I cannot have my value of z be equal to 1. Therefore, there is no solution. For this one here, hopefully you recognize that you can factor all of your denominators. So I looked at my denominators. I factored out a 3 out of the first one, giving me 3 times n plus 1. I factored out a 4 in the second term, which gives me 4n minus 1. And in my last term, I can factor out a 2, which gives me 2n plus 1. So my lowest common denominator is going to be 3, 4, and 2. Lowest common multiple between 3, 4, and 2 is 12. And then I have an n plus 1 and an n minus 1. So my lowest common denominator is going to be 12, n plus 1, n minus 1. Along with that, I do recognize that n cannot be negative 1, nor can it be a positive 1. So I have two constraints there that I need to keep in mind as I work out the rest of the problem. Multiplying each term by my lowest common denominator, I end up getting 7n times 4 times n minus 1 minus 5 times 3 times n minus 1 equal to 3n times 6 times n minus 1. Distributing out, combining like terms, moving everything over to one side, I end up getting 10n squared minus 25n minus 15 equal to 0. I can then factor out a 5. Moving all my terms to one side and setting it equal to 0, I get 10n squared minus 25n minus 15 equal to 0. You could also factor out a 5 out of the left-hand side. Makes it a little bit easier to factor later on. So you have 2n squared minus 5n minus 3. That factors into two binomials. Those two binomials are going to be 2n plus 1 and n minus 3, which means either one of those making the value 0 would be a possible solution to my equation. So if I set the 2n plus 1 equal to 0 and solve, I get n is equal to negative 1/2, or the n minus 3 being 0, n would have to be equal to 3. So I have two possible answers, a negative 1/2 and a positive 3. Both of them are not part of my extraneous roots portion. So therefore, both of them can actually work. If I plug them in and check, they both indeed do work to solve this particular problem. Looking at that middle term, I'm going to go ahead and factor that into two binomials, p plus 4 and p minus 2. That means my least common denominator is p plus 4, p minus 2. I then look at what my values of p cannot be. It cannot be a positive 2, nor can it be a negative 4. So those are some constraints that I need to remember later on. Multiplying each of my three terms by my common denominator and canceling out, I get p plus 4 equal to 2p plus 1 plus 2 times p minus 2. Go ahead and distribute, combine like terms on each side, move everything over to one side and your non-p values over to the other side, and you end up getting 7 is equal to 3p. Dividing both sides by 3 gives you a value of 7/3 for your p, which is not part of my constraints. Therefore, it probably will work. When you plug it into the original equation, it does indeed work. So if you have 7/3 or 2 1/3 as an answer, you have the correct answer. Now that brings us to what I'm actually going to be teaching tomorrow. But I want to give you a little bit of a head start on what is going to happen, because it helps to have more than one day to kind of grasp your mind around this particular topic. So I'm going to introduce it today, but you don't have any homework tonight on this. However, like I said, it is better if you get a little bit ahead right now in at least the thinking process, subconsciously even. We're going to be discussing what we call weighted averages or mixture problems. So weighted averages help find the average of a set of numbers where you have a particular value that repeats more often than others. We have weighted averages in like the periodic table. Carbon 12 is defined as being exactly 12 grams for one particular mole of carbon. However, because of the different isotopes of carbon, such as carbon 14, the actual average is just slightly above, but there's a whole lot more carbon 12 than there is carbon 14. So the weight of carbon 12 in the average is more than what the weight of carbon 14 would be. It'd be similar to, let's say you had 10 tests throughout a quarter and you got 98% on 9 of those 10 tests, and you got a 70 on one of those 10 tests. Well, your average is going to be a lot closer to the 98 than it is the 70, because you scored more 98s than you did the 170. So that is what we call a weighted average. They're used for mixture problems, they're used for work problems, they're used for distance problems, and also for interest. We're going to be looking at a couple of those as we go through this particular section. But I just want to introduce it to you today and hopefully help you to understand how you work out these problems. So let's just say that Hannah adds a 70% solution of an acid that she has to 12 milliliters of an acid solution that is only 15%. So she wants a higher concentration of acid. She's got a 70% solution and she's got a 15% solution. She's got 12 milliliters of the 15%, and she wants to raise that percentage all the way up to 60%. So she's going to obviously have to add more of the 70% than what she had with the 15%. So it is helpful to make a table. This is something that your book does not teach exactly the way I'm going to teach it, but I think this method is a little bit easier. So here's how I would set up this particular table. And I put all the numbers in so that you could see where it's going first, and then as we work out example problems, you'll have to fill in the actual numbers yourself. So to begin, I have my original solution of 15% solution. I have a 70% solution, and then I have my final solution that I want to be 60% solution according to my problem here. How much do I have of the 15% solution? I have 12 milliliters of it. How much of the 70% solution? Well, that's what I'm trying to figure out. How much do I need to add to this 15% solution in order to get what I want? Over here, as far as the percent, I've got the 15%, which is 0.15 as a decimal, 70% is 0.7. You could have 0.70 if you would like. Over here, I'm multiplying these two numbers together. So 12 milliliters times 0.15, this gives me the total amount of acid that I have in my solution. Then I have the 70% times its unknown quantity, which is 0.7x. And then in my final, I'm going to have these two numbers added together, because how much am I going to have at the end? Well, I'm going to start out with the 12 milliliters here, but then I'm adding, let's just take a number, let's say I added 50 milliliters, then that would give me a total of 62 milliliters at the very end. I don't know how much I'm adding yet, so I just made that 12 plus x. This one here, I want a 60% solution. That is based on the problem here. And if I multiply those two together, I get 0.6 times 12 plus x. This number times this value. My next step is to set up an equation. I want these two being added together to give me this final amount. So I have the 15% of the 12 milliliters plus the 70% of my unknown amount should give me 60% solution of the total amount, which is 12 plus whatever I add to it, the X value. If I distribute this and I multiply the 15% and the 12, I get 1.8 there, plus the 0.7x is equal to 0.6 times 12 is 7.2, and 0.6 times x is 0.6x. Now I need to combine all my x terms. So I get my x terms on one side of the equation, my non-x terms on the other side of the equation, so that I can solve for x. So I'm going to subtract 0.6x from both sides, and I'm going to subtract 1.8 from both sides. When I do that, I get 0.1 is equal to 5.4. Multiplying both sides by 10 or dividing both sides by 0.1 will give me my x value of 54. So I would have to add 54 milliliters of the 70% solution, and that would give me a total of 66 milliliters of a 60% solution. Setting up the table setting up the table is going to be the most difficult portion of this, but the more you do, the easier it will become. Let's work out another problem. Let's say we have blackberry tea and also black tea that we're making a mixture, and we want a certain amount of that mixture as far as price. For the blackberry tea, it is sold at $25 a pound. For the dried blackberries, it's $10.50. Black tea is $35 a pound, and 5 pounds of blackberries. How much tea do we have? Setting up our table, I have blackberries, the number of pounds, and how much it is per pound. I have the black tea. Go back to the beginning of that one. So here's another mixture problem. In this particular case, we are mixing 3 different types of ingredients. I have blackberry tea, I have actual dried blackberries, and I have black tea, and I'm mixing them all together to come up with a certain concoction and how much tea I need. So I set up my table. I have 5 pounds of blackberries. I don't know how much tea I am going to have. And then I have my blackberry tea, which is going to be 5 pounds plus the X. So I'm mixing blackberries in with the tea to get blackberry tea. That's the idea. Let's go back. Here is another mixture problem. In this particular case, we have tea and we have blackberries that we're going to mix together in order to get a certain brew of blackberry tea. I'm starting out with 5 pounds of blackberries, and I have 25 pounds. My blackberry tea costs $25 per pound when I sell it. The dried blackberries are $10.50 a pound, and my black tea is $35 a pound. I'm using 5 pounds of blackberries, and how much tea am I making? So I've got 5 pounds of blackberries at $10.50 a pound. If I multiply those two together, I get $52.50. I have my tea, an unknown amount of pounds for my tea, but I do know it costs $35 a pound. So if I multiply those two together, I get 35x. And then as far as my blackberry tea is concerned, I have the 5 pounds of blackberries plus the unknown amount of tea that I'm adding together. I want it to be at a cost of $25 per pound. If I multiply those two together, I get 25 times x plus 5. I know that these two added together should give me this amount right here. So I'm going to take the 52.50, I'm going to add the 35x, and I'm going to set it equal to the 25 times 5 plus x. Distributing that 25 times 5 plus x gives me 125 plus 25x. Now I've got a very simple algebraic equation that I can solve for x. I'm going to subtract 5250 from both sides. I'm going to subtract 25x from both sides, giving me 10x is equal to 7250. If I divide both sides by 10, I get 7.25. So I need to add 7.25 pounds of tea to my mixture in order to get the proper mixture of my blackberry tea. How many pounds of premium should be mixed with 2 pounds supreme to make a blend? If the premium costs $9.50 a pound, the supreme costs $11.75 per pound, and I want my blend to cost a mere $10 a pound. Now let's set up a table. We're going to begin by writing out our table with columns and rows. So I have an amount, I have a price, and then I have a total column for my 3 columns. And then for my rows, I'm going to have premium, supreme, and then the final line is going to be my blend. So my table begins looking like this. Now, my premium, how many pounds do I need? Well, that's what I'm looking for. It's asking how many pounds of premium should be mixed. So I don't know what that value is. What is the price per pound of premium? Well, it's $9.50, so I'm going to put in $9.50 there. Okay. Now, how much supreme do I have? Well, I have 2 pounds of supreme, so I'm going to go ahead and put a 2 right there in that column, which means my total blend is P plus 2. Now I'm going to enter in my prices. My price for premium is $9.50 per pound. My price of supreme is $11.75 per pound. If I multiply these two together, my blend I want to be $10 a pound. So I'm going to go ahead and put the $10 in there. Over here in this first column, the total number of pounds that I'm going to have is 2 plus whatever I put in as my premium, so P plus 2. Now for this final column over here, my total price is going to be P times 9.5. My total price here is going to be 2 times the 11.75, which is going to give me 23.50. And my blend is going to be 10 times my P plus 2, which gives me 10p plus 20 when I go ahead and distribute that. If I take this last column and I add these first 2 rows, I should be equal to my third row. So that's exactly what I'm going to do here. I take the 9.5p plus the 23.5 equals 10p plus 20. I'm going to get all my p's to one side, so I'm going to go ahead and subtract 9.5p from both sides, and then I'm going to subtract 20 from both sides. That gives me 3.5 equal to 1/2 p. Multiplying both sides by 2 gives me a value of 7. So I need 7 pounds of my premium in order to make the tea that I want.